key person for this award package. So I would like to thank Mari Feinberg for excellent job highlighting all your amazing accomplishments. Now I'd like to introduce Professor Umit Oskan, who is the current department chair of chemical engineering at Ohio State. I think in addition to Elspan, I think Umit was always my mentor. She's still my mentor. So whenever there's a panic moment, I'll be calling her and say, what do I do? I think that much, I think the mentorship and education goes beyond their own group. And I think that I really appreciate about the Ohio State. And she's the world-known expert in catalysis. So let's welcome Umit.
Thank you, Alyssa. Good afternoon. It really gives me a great pleasure to be part of this celebration, honoring Professor Ellis Fan for receiving the Warren K. Lewis Award. As the AICHE's highest honor in education, the Warren K. Lewis Award is named for one of the founders of modern chemical engineering and recognizes distinguished and continuing contributions to chemical engineering education. So it is more than fitting that Professor Fan, who was named as one of the 100 engineers of the modern era by AICHE at the AICHE's centennial celebration in 2008, should receive this honor. I think it's very fitting. Professor Fan, or Ellis, as many of us know him, is being honored for his multifaceted contributions to chemical engineering education, including outstanding research that led to seminal contributions to the literature, highly effective teaching, extensive student and faculty mentoring, outreach to diverse groups, the general public, and K-12 students. And the Ohio State University and my department is really proud to have been the fertile ground in which Ellis's work and career grew and flourished over the past 4.5 decades. So Ellis's journey at Ohio State started in 1978 when he joined the faculty as a very young assistant professor. Of course, rising through the ranks very rapidly, he received every honor, every recognition that Ohio State University or the College of Engineering espoused upon its faculty, including being named a distinguished university professor, alumni distinguished teaching award, distinguished scholar award, and of course the Sullivan Medal. Of course, its recognitions are not really limited to Ohio State. He received many national and international awards, including being elected to the National Academy of Engineering, as well as to the Indian National Academy of Engineering, Chinese Academy of Engineering, Australian Academy of Technology, Science and Engineering, and Mexican Academy of Sciences as a foreign member. Ellis took on the department chair role at Ohio State in 1994 and led the department for 9 years. His leadership really transformed the department into a hub of innovation and excellence, ushering significant achievements in research and teaching in a collaborative environment where faculty and students flourish and thrive. As an educator, as a researcher, and as a leader, as well as a mentor, he led the department to new heights. He established very close ties with our alumni, and those ties were really instrumental when we were getting ready for our new building. They supported us very generously. He led the centennial celebration of our department when we celebrated our 100th-year anniversary in 2003, and it gave a lot of visibility to our department. He led the name change of our department when we recognized the importance of biology and biological science our name to chemical and biomolecular engineering. His leadership as a department chair really provided a roadmap for us to pursue. It's a roadmap for excellence. And it's the roadmap that I try to follow as a department chair for the last 4.5 years. Ellis always leads by example. He sets very high standards for himself and for his colleagues and his students to aspire to. His productivity is unmatched. He has co-authored more than 450 journal articles, I think for 90 something to be exact, over 70 patents, 6 books, including highly adopted textbook Principles of Gas Solid Flows. Another one of his books, Expanding Global Chemical Engineering, has gained popularity with general audiences as an introduction to chemical engineering. He has delivered 36 named lectureships globally. Ellis's pioneering work in multi-phase flow reaction engineering revolutionized the field, and we have heard some great examples this morning from people who are working in the field. Especially through integration of particle science with the multi-phase reaction engineering, it really revolutionized the field. Believing that particle technology has not received its due consideration, he became the founding chair of the AICH's Particle Technology Forum, and he's the editor-in-chief of the journal Power Technology for several decades. An exceptional aspect is his talent for bridging the gap between theory and practice. Very few people can do that so seamlessly, so effortlessly. The students not only learn from the fundamental principles of chemical engineering, but they also have the privilege of witnessing these principles come to life through first-hand exposure of real-world applications. Of course, this enhances students' educational experience so that it is both intellectually stimulating and relevant on a practical basis. Ellis has been very successful pushing research from his labs into industrial applications. His research addresses some of the most pressing societal and environmental challenges and is paving the way for more sustainable and environmentally friendly processes in various industries. We are very excited that this chemical cooling technology has garnered a lot of interest and is licensed to Babcock & Wilcox and is really on its way for large-scale industrial applications that will have huge implications for energy as well as chemical manufacturing. Ellis's unique ability to excel both as a scientist and educator is really a testament to his exceptional dedication, his vision, and his commitment to advancing the field of chemical engineering. Seamlessly combining these roles, his capacity to inspire and educate future generations while simultaneously pushing the boundaries of scientific knowledge really underscores his extraordinary contribution to academia and to the engineering profession. I think Ellis's career is a living proof that effective teaching and groundbreaking research need not be mutually exclusive. His passion for knowledge dissemination and relentless pursuit of scientific excellence have not only expanded the frontiers of chemical engineering, but have also produced a generation of engineers and scientists who are exceptionally well prepared to address the complex challenges of the modern world.
Speaking on the point that LS is a true legacy person within the AICH So I'm going to give a few interesting, I hope, perspectives, and we'll take it from there, okay? First of all, at AICG, we have 3 strategic initiatives. LS hits it on all 3. If you think about it, I can't speak to all of his technical accomplishments. You all are doing that here every day. The books, the number of publications, the fact that I've checked, he has chaired or co-chaired 118 technical sessions, over 201 chemical engineering papers at our conferences, one of the founders of the Particle Technology Forum, and this just barely scratches the surface. So all the accolades of the technical, this truly aligns with the strategic aspect of what we do in AICG to help promote the technical advancement of our profession. Thank you for all that, Alex. For the career of the individual, we're seeing how many PhD students he's supported, how many mentors and friends he's been to everyone, the legacy of excellence that he has set for moving us forward, as well as being an outside teacher. So on the individual, to help individuals in their advancement, home run, no question about it. And I can say for myself, having known LS Van from the Particle Technology Forum days, as an individual, he was kind. He never took a moment hesitation to stop and reach out to you and talk with you at a Particle Technology Forum dinner, in the halls of the AICHE meeting, or wherever you'd see him. He took true interest in researchers, young and of different areas. This is admirable. If we could only do this more at AICH, it would be better. Another home run. I'm going to choose a bit to talk about societal, because in addition to AICG, from the technical, the individual, and using chemical engineering expertise to help societal, that's the area that becomes most challenging in our profession, is where do we have concentrated specific examples where we can show we have taken our expertise to help society. Ellis is a rock star in this too. And in particular, he went through the succession for a Societal Impact Operating Council and was also the lead contributor to a high school education project called Active Chemistry that I'm going to talk about here in a minute. Everything that we do in AICHE also has an underpinning of diversity, equity, and inclusion through our ideal statement. Again, from the earlier papers that I'm seeing here today, LS has been a champion in promoting diversity, equity, and inclusion within our profession. Which leads me to believe that I think, and it's coming off the top here, LS I would consider a Renaissance professor. He hits on all the areas. So I'm going to talk for a minute about what is a Renaissance man. In this case, I'm going to call it a Renaissance chemie. There's an article that came out on a website called The Helpful Professor just about a month ago. And it says, what are the top 18 Renaissance man characteristics that a professor should have? Let's take a look at these. Ellis hits them all. Well-rounded education, free thinker, analytical, multilingual, well-read, sociable, brave, charismatic, true gentleman, artistic culture, well-traveled, explorer, and investor, entrepreneurial. Look at the companies that he's brought forward. How many in our profession have the entrepreneurial spirit to move it forward? It's a rare few. Effortless and humble. So my characteristic of what we have at AICG, Professor Fan is truly a Renaissance chemical engineer that we should all aspire, whether you're male, female, etc., to be in that regard. So let's go back to the program called Active Chemistry. I just Googled it this morning, and you can still buy the first edition. It's in the second edition. It was an NSF-funded project. And LS was key in developing sustainability and energy chapters for it. And it's now in its 6th edition, still being sold to high school and middle school students. It is an active learning approach for teaching chemistry from middle school students and through high school students. And it's meant to be chemistry for all. Not only is it its 6th edition, but the very first edition, AICHE, with LS's leadership through our Societal Impact Operating Council, engineers, with the other people that are involved with it. And you can still buy the books. Now, we haven't sustained the relationship, but I wish we had. When you consider how we're doing outreach and how we're so worried today about we have enough chemical engineers coming into the pipeline, this was a start. And maybe this is something we'll continue on to do. But what's really interesting about this is I'm going to take a moment and go through some of the aspects of active chemistry from that time. And it just so happens that one of the first presentations we did was in 2006. That's almost, can you believe it's 20 years ago? And this is when I first came to the Ohio State campus for this project and met Alicia for the very first time. And it's almost 20 years ago. Can you believe it's that long ago? No. So this is active chemistry, and what this was a presentation that we gave to the Societal Impact Operating Council, and it was done in the spring meeting in Orlando, almost 20 years ago. And we talked about how we presented the sustainability component with the group that helped work on these under LS's leadership, including John Parsons, Herman Gupta, Peggy Sheets, if you remember the high school student that we worked with too. Now, I'm not going to bore you with all the details of the presentation, but if anybody wants to know, it really was an exciting program where we developed a number of areas to help promote the sustainability team, how we could involve AICHE on many aspects of its implementation. We had writing teams on doing things such as cooking chemistry, fuel cells, sports drinks. The fuel cells one was really trying to make it very important to get an early area in energy some 20 years ago. We had 15 chapters and projects. All we're done is open-ended problem solving, implementing engineering design with the students. And what was really interesting is we did pilot teacher training, and we did it at the Ohio State campus. So what we did was we brought to the Ohio State campus all of the high school teachers that were selected to initially implement this project, and we were there for 2 weeks, living in the dorms at Ohio State, working on the laboratories, because these were all laboratory-based, and the high school teachers would work to train. And it was probably one of the most fun that I've had in many summers, being a freshman again at Ohio State, in the dorms, implementing things on a daily basis. And I still keep in touch with some of these high school teachers that we were involved with at that time. The sustainability chapters were one was the design of the tennis shoe. And more importantly, end of life, what do you do with all the tennis shoes that are out there in order to keep them out of landfills? So it brought in the principles of design, it brought in the principles of recycle, and many of the things that we're doing now with plastics, and looking at what we're doing with end-of-life issues were included in these. It's water, can you drink it? It was about water purification and bringing that to the middle school and high school students. And then also how you design a fuel cell vehicle, which is really kind of all based on what we're doing with the hydrogen economy right now. So again, I'm not going to go into the aspects of it with more detail, but the point being is that active chemistry was a wonderful project. It is probably one of the best projects that AICHE has had that shows how we take chemical engineering expertise and implement it into society. And I really have to thank Ellis's leadership for getting it started. And again, I think you can all join me in agreeing that Ellis truly is the epitome of the example of the Renaissance chemical engineer for our profession. And I thank you, Ellis, for your leadership. So thank you very much.
For the Professor Fan for different areas. So this section is mainly focused on the Professor Fan's impact on industry. Right? So, but congrats again for this award. And this is a list of the previous professor students that work in the industry. And so as this is a group of people, I said just coordinate. So that's thank you guys again for your spent effort to prepare this talk. So we can start from the first PhD student, Terry. Let me get the slide there.
Good afternoon. Can you hear me okay back there? Okay, thank you. First of all, congratulations, Dr. Fang, for this prestigious award, which is really, really outstanding. I'm happy to be here because I feel like I have a personal attribute which I really want to give in person. Before I start, let me give you a brief introduction about myself, so that I put my appreciation of Dr. Fang in perspective. First of all, Dr. Fang is not just a professor to me, he's a teacher to me for life. By that I mean that he's always a role model for me, and that role model goes with me throughout my career. So I've been thinking about what kind of word I should use to show my appreciation. And among all the teachers' appreciation I can find, this is the one resonates with me the best. Okay? I'm indebted to my father for living, but to my teacher for my living well. And this is not mine, this is from Alexander the Great. Okay? And I can really feel about it. And about myself, I'm Dr. Fang's first PhD student. I went to Ohio State in 1979 in the fall, September, and I got my degree in the summer of 1982. And this 3 years turned out to be the most important year in my life. Okay, and after I graduated, I was able to temporarily work at the UC San Diego for 2 years. Then I moved on to working in the industry. My first job is with DuPont, which started in 1984. DuPont recruited me to help them develop Kevlar fiber, which is polyaramid-based material. And then move on. At that point in time, I don't have any, I don't use any of my PhD dissertation knowledge, which is fluidization. All I'm working is about new polymeric material and applications. So this is the starting point. I depart from the traditional chemical process engineering. I started into a lot of product and application development. Fast forward, my last job in the industry is with Honeywell in technical director and the CTO capacity for almost 18 years. And the highlight of my Honeywell career is last few years in Honeywell, my team has developed a new material for the armor, for the bulletproof vest and a helmet. Okay? So today, if you look at the US Army and the US policemen, the apparel they wear, the helmet they wear, about 2/3 of the material was developed, invented and developed by my team back in Honeywell. So in about 2015, I received a Lifetime Achievement Award by Honeywell. And at that time, I feel like this is a great time to think about what's next. So I spent about a year to find my successor, and then in 2017, I retired from Honeywell. And from 2017 to today, play different roles. I have my consulting company doing some consulting work, focus on the product development. And also I have my own family foundation, which is to promote the youth leadership development. And also, the most fun job is as a professor at the National Taiwan University, which is the position Dr. Feng connected me to our alma mater, National Taiwan University. And I offer a course which is basically pioneer a new curriculum in chemical engineering, which is about the chemical product engineering as opposed to traditional chemical process engineering in most of the universities curriculum. So I teach people, the students, how to use the chemical principles to develop a product and went on to commercialize it. So there's a process and tool I teach them how to use. So this is about myself. And so for Dr. Feng, the reason I'm teaching him so much is that in 3 years at Ohio State, it prepared me to begin my industrial career. And when I finished industrial career, after 32 years, he again helped me to connect a job with the National Taiwan University to be a professor. So I'm very happy to be back in the academia, although I missed that part in most of my career. So I'm thinking about what I can use in one word to describe Dr. Feng. And pivotal is what I can come up. And I think it's very appropriate to me at least, because as I mentioned, there are two critical points in my career. Dr. Feng plays a pivotal role. The beginning of my career and industrial career and the end of my industrial career. And also, for pivotal, right, if I break this down, I can break this down to a few key words which can really describe Dr. Feng's leadership among many things, and that makes him so outstanding. And I just want to share with you what they are. So first of all, P stands for passion. Dr. Feng is passionate for whatever he does. Technology development, people, his family, passionate. Impact. We talk about impact in the society, impact on technology, and for me, it's impact on career and individuals. Dr. Feng has almost 100 PhD students, and that by itself is a huge accomplishment, but it doesn't stop there. Because remember, the power of a compound, the people Dr. Feng developed, including myself. I like myself, I've been in the CTO capacity for many years, and I promote people to be a manager, to be a director, and they went on to develop their people. Just think about this multi-generation impact, which is huge, huge. Value. The value-driven mind. I think best describe Dr. Feng. Just think about the technology he's developing, or he has developed, impact on the society, so value. Ocean. Ocean is vast. I like ocean because it's vast. It has a lot of nutrition to support numerous life in the seas. And Dr. Feng is ocean life. He has a big heart. He's very resourceful to the people and to his colleagues in the work environment. Teacher. I really think teacher is the best thing that God created. Because of teacher, you can mentor people, can be a role model to people. And Dr. Feng, no doubt, is a great teacher. Ace. always the best of the best, right? He always try to be the best in whatever he takes responsibility for. And that's why he wins this award. Last but not least, L. Linchpin, I use the word linchpin. Linchpin is a pin which connects the moving part of the machine to keep the machine functioning and moving. So I think Dr. Fang is a linchpin to this big organization, to the department. The role he plays is crucial, and there are so many moving parts, and he's able to put it together and then make the move coordinated. So with a few words, I just want to thank Dr. Fang for all the things he has done for me. Last but not least, since you all show some pictures, right? I don't feel I can finish my presentation without pictures. And also for Dr. Fang, right, my appreciation goes beyond just you, also go to Sue. Because ever since we came to the country back in 1979, we were very young, and Sue is one of our big sisters. Really, really take care of us. So our appreciation and love goes to you, Dr. Fang, and to Sue. I wish she was here today, but we miss her. So you see that the left side is 1981 picture. She's the guy in the right hand side is such a young, handsome person. And the one on the right, 2017, Dr. Fang is 70%, which is still very, very young. So I have reserved 3 more picture spots, 10 years apart each. So the next one we do when you are 80s, 2027, and then 10 years after that, 10 years after that. So please stay well, and then give Sue a big hug for us. Thank you very much.
He's traveling in China now, so he cannot attend his conference. But he let me to record these slides and let me to show that. Before that, I just kind of quickly introduction Dr. Ping Kai. He is a principal scientist, licensed process technology manager at WKL. His expertise in advanced quantization process technology. In his career, related to uniform polyethylene polypropylene process, he has worked for Unilever, Chemical, and Irrigation Technology. He also worked with electricity and Team White in the field of validation, reaction, and engineering.
Good afternoon, ladies and gentlemen, friends. It is so exciting we are here yet together to celebrate and congratulate Professor Fang for the Warren K. Lewis Award, which he fully deserves with his outstanding academic and industrial education record. I am honored to tell you something about Professor Fang from the viewpoints of his former student and an industrial practitioner benefit from his education, advisement, and mentoring for over 30 years. I am sure most of you have known many different roles of Professor Fang, and all familiar with his very remarkable work. He is an educator, a true scholar, a researcher, an inventor, a leading innovator, a pioneering practitioner, and an entrepreneur. The story I am going to tell is particularly related to his role as an educational contributor to industries. I am not talking about his contribution by educating so many outstanding engineers, including many of you in this room. I will tell a story which is less known for a long-lasting technology with very significant commercial impact. The story is related to the gas-solid fluidized bed process making polyelements. This is one of the most widely used technologies in making commodity plastics, polyethylene, and polypropylene. The famous examples are unipolyethylene and polypropylene processes, originally developed by Union Carbide Corporation, which is also the company I used to work for. As of today, Unipo-P and PP technologies have been licensed to more than 265 lines worldwide, with 165 plus for polyethylene since 1968 and 100 plus for polypropylene since 1985. Unipo-P process is also the winner of Kirkpatrick Chemical Engineering Award. In such a process, the unreacted monomer and other materials leave from the top of the fluidized bed reactor, carrying the reaction heat going through a compressor and a heat exchanger, then recycle back to the bottom of the reactor together with the makeup monomers. The operation criteria until early 1980s is the cycle gas after cooling cannot be condensed. This is to avoid liquid in gas-solid fluidized bed. However, people did enter the condensate by mistake or by trial. That is, with the cycle gas passing the heat exchanger, cooled the defect. What's the consequence? Sometimes very bad things happen, such as polymer corroboration in reactors, distributor plates got clogged, defluidization zone, etc. While some other times, the operation is fine and even with enhanced performance. Why? What's the mechanism behind those observations? Can a gas-solid fluidized bed be ever operated stably with condensates? The pioneers of the uniform process development were very lucky to have a real expert less than 200 miles away at the Ohio State University. He is Professor Beck. Facing this entirely new subject, as Professor Beck confidently interpreted the case as a special gas-liquid solid fluidization with liquid discrete phase, that is type EIB or three-phase fluidization, which the upper part of the reactor is being gradually changed to gas-solid fluidization through the evaporation of the condensates. He confirmed that such a system can be operated stably with proper control following certain technical principles. Those principles are not provided here since they are still sensitive information. You know what? That turned to be one of the best examples of an educational contribution to industries. As of today, condensing mode operation is a very common and dominating operation pattern for fluidized bed polymerization process. It can significantly promote the production rate of a given reactor and also improve the reactor operability. His book, Gas, Liquid, Solid Fluidization Engineering, has become the Bible in the field of three-phase fluidization, where you can find all kinds of answers. I am so lucky to be Professor Ben's former student and am very proud of that.
you know, in this slide, you can see that very famous, you know, festival has 72 students. Okay, and 2 days ago, somebody told me that Dr. Fan had 96 PhD students, which is 30% more than, you know, Mr. Hong. So I think, yeah, this is very important because for a lot of people, Dr. Fan is, you know, the great researcher, you know, inventor. But for me, Dr. Fan is a teacher, a professor, a mentor, advisor. So I mean, for me, you know, all these students make, you know, Dr. Fan actually this kind of great educator. That's what I think. Okay. And in my time, you know, we had around 20, 30 students in Dr. Fan's class. And I mean, Dr. Fan, at that time, I really understand how that he had, you know, meetings, sub-group meetings, one-on-one discussions every week with all these students. So I mean, for me, you know, if you don't have, you know, 40 hours, 50 hours per day, you cannot maintain all these kind of things. So I don't know, you know, how many hours does Dr. Fan have for each day, but I'm sure it's not 24 hours. And the only time I don't need to worry about to meet Dr. Fan in the office is the Sunday morning, I guess. That's the only time Dr. Fan is not in meetings. Maybe he's in the office. Anyway, okay. And you know, also, you know, Mr. Kong is very famous because, you know, he has so many students, but he treats all these students in different, you know, very specific way for each student. And I'm sure Dr. Fan has, you know, his very own recipe for each student because every student is different, and the person, you know, Dr. Fan is trying to, you know, guide them and mentor them in different ways. For me, I am, you know, a guy a little bit busy, but I can do things pretty fast, but the trade-off is, you know, the quality. You know, a lot of times, you know, my work has not that great quality. So, I mean, every time when I show my progress or whatever to Dr. Fan will always let me know, okay, you need to be slowed down, you need to, you know, get deeper, get, you know, a little bit more detailed stuff, you know, try to dig more from all this, you know, data. Basically, I learned a lot from Dr. Fan about how to do things. Okay, I can still remember that, you know, the first time, you know, I presented in the SAT. At that time, I prepared some slides. Yeah. Of course, at that time, I had to show my slides to Dr. Fan. And Dr. Fan spent the whole morning, I'm sure pretty much, you know, the whole morning with me, you know, modifying everything, you know, polishing the slides, prepare the presentation, word by word, even change some, you know, data points color, make it a little bit more clear to the, you know, auditor or like that. So I mean, for me, you know, it's already pretty good. You know, for me, I spent, you know, 1 week on these slides, so I feel pretty good. It's good enough. But Dr. Fan, you know, talked to me about, you know, I can still remember the word what he said is something like, you know, good enough is not good enough if you can do better. And be better is not good enough if you can be best. So I mean, we spent the whole morning, and also Dr. Fan asked Dr. Brodke at that time to teach me how to pronounce the word hypothesis. And maybe today I'm not pronouncing it, you know, correctly, but I practiced maybe 100 times. I don't know. And also I presented to Dr. Brodke and Dr. Fan
me, it felt like a minus 273 degrees Celsius, absolute zero. So it's crazy to see part of the cultural shock when you go to Ohio State. I think that in that time, the Bobcats won the national championship, and you go and see all these people running in t-shirts and shorts when it's freezing outside, so it's just cultural. But I was honored to be part of the fan group. And last night, I did a quick Google search of who is Dr. Fan. And as you can see, Dr. Fan is the king of gods. You know, that level, but let's not go there. Any jokes aside, I think Dr. Fan, as you know, is an outstanding professor. I mean, he has won several awards. The university has recognized that outstanding university professor, Sullivan Medals, etc. And I can say that I was privileged to be one of his students. I remember the first class that I took to Dr. Fan. He came in with a binder of 500 pages full of post-its. And I said, okay, this is what we're going to see in the entire semester. And Dr. Fan opened the binder and said, okay, this is what we're going to see today. And it's like just amazing, you know, all the information that he has stored in his head is just, I think before the invention of the artificial intelligence, I believe Dr. Fan downloaded his head into ChatGPT, because when you go to his class, the transfer rate of information from him to you is just amazing. It's just like a 50 gigabytes per second. You have to be prepared when you go to his class. It's so much information he has to tell you, and it's not enough. So thank you for Dr. Fan for your teaching. It's outstanding. There's no question about it. He's an accomplished researcher. Have you seen his resume? I mean, there's no question about it. It's this thick. So when you go there, I think everyone knows the accomplishment that you have done through the years. It's just amazing. For me, Dr. Fan is also a mentor. He's a role model. He's someone you can aspire to be. And not only that, on top of that, if that wasn't enough, he's actually, over the years, has become a trusted friend. You know, he is the person that will never let you down. He always says what he's going to do, and he does it. He accomplishes it. So if he says something, it's going to happen, it's going to happen. One of his main qualities that I have learned through the years with Dr. Fan is that your success is his success. So, Dr. Fan, and as Pink has said, he has such a high expectations of you, and I think that's a whole motivator that inspires you to do well. And there is no other choice but to be successful. If Dr. Fan has said you have to do something, it's on you. You have to do it. And I'm going to say something also that I have learned through the years. When you talk to Dr. Fan, Dr. Fan has a peculiar way of telling you something and make you feel that you are the one. You are the special person. When he called me and said, hey, Louis, I want you to give a small talk in my honor. I'm receiving the teaching award, yes, achieved. Your talk is the most important. Wow, that's all the responsibility now falls on me and all the pressure to do well. And I think that motivates you to do well. I think there is no question that whatever expectation the woman has is on you. All the quality is that whatever he does, whatever research he commands you, has meaning. It's not just the fact of doing research, it actually has meaning, and your actions has consequences, really consequences. So moving do research with Dr. Fan, and we research chemicals. And I think by now, I hope you already know that he has invented chemicals. And that's such a game-changing technology. It's an amazing technology. You can take a variety of fuels and transform it into hydrogen and a sequestrable CO2. How beautiful is that? The most efficient, it's a game-changing, but the true discovery, the true breakthrough is on the particles. That's where actually the technology happens. It's not just the technology, it's the particles, what has all this knowledge, technology, and invention is buried in this particle. And normal people see this particle like me, or we see it, oh, it's nice, it's cute, it's round, it's red. But Dr. Fan, he has other ideas. He sees quantum states, he sees oxygen vacancies, he sees alternate states there. He doesn't see a particle, he sees the possibilities. And I swear, he has probably a density functional theory running in his head as simulation. And when you ask him a question, he just tells you, for example, oh, you need to put, you need to combine it with a particle that has a molecular weight of 159.63. Go ahead, do the research and prove me right. So he's that good. You know, he really knows what he's talking about. Obviously, the research has led to several books, hundreds of papers. It has inspired other people to do research on chemical looping. The Department of Energy has programs dedicated to chemicals. So it just transcends the research that he does. Obviously, moving forward, I graduate and become part of a great company, the Back They have 150 years history of being part of technology. We have done it all. Anything that you can think of a power plant, we have done it. Oxygen combustion, wet scrubbers, dry scrubbers, wet SPs, amine scrubbing. We have demonstrated that at the National Carbon Capture Center. Membranes, and I can tell you right now that chemical looping has other advantages. We have analyzed each and every technology out there, and we see it as a game-changing technology. And for that reason, BMW has fully licensed Ohio State technology exclusively for the production of hydrogen. And we are in the process of demonstrating that. So continue. Once I joined BMW, Dr. Fan didn't stop there in the lab. He wanted to take this technology to commercial level, to demonstration. So with the collaboration with the Back company and Dr. Fan leading this project, we built a pilot demonstration to convert syngas into hydrogen. As you can see, this is not a joke. This is actual equipment. And we have always had to build and design this unit. And we can tell you the demonstration went really well. It demonstrated hydrogen impurities 99% high. We didn't stop there. We did another pilot demonstration now back at the Clinical Center. And now we convert to solid fuels. And we demonstrated as well, very successfully, we can convert carbon 100%, get very high purities of CO2, above 99%. Now we're excited to say that this is publicly. We're taking the technology to a commercial level, and we have several projects now lined up with this technology. We have a project in Baton Rouge, Louisiana, to produce hydrogen from biomass, carbon negative. So we plan to sequester CO2. It's a 20 tons per day hydrogen production. We plan to start in 2026, and project in Massillon, Ohio, a small demonstration plant, 2 tons per day for producing pattern for natural gas. So this is becoming real. I think Dr. Pam, like he said, I'm going to commercialize the technology. I think it's going to happen, and it's becoming real. And collaboration between Ohio State and Babcock and Wilcox is just growing strong. Right now, we have a contract with Japan to do research and to continue the development of chemical refining. And now it's the responsibility of the new generations to carry the legacy, and they're here. So please, Rush, Shani, Shepard, and Shigis, and some other mining scales, you have a tremendous responsibility. So, welcome. Thank you.
Good afternoon, everyone. Thanks for it's my privilege to give just an introductory or a little presentation about the impacts that I respected, the impacts of Professor Fan on research. So, one of the things personally, Professor Fan has been the most influential person in my life for all my professional development. Second only to my parents. Since my career began working with him, and had the privilege of working with him throughout the entire development. So I wanted to give a brief introduction. So I break this up into a couple of points of research work, technology that he has done. Break this up into the research work and the technologies that he has been developing. So some of the couple of things that predated actually my time when I was joined in 2010 and working on some technology, working on primarily on the right side, development projects for chemical looping. I want to give at least honorable mention to some of the core things that he's done great research work that has really influenced the industry. As Kai mentioned, he was very monumental in the development of the Unipol process, for the condensate mode operation of the process. But he also worked on each oil process, developing the operating procedures for the firm. And he is the founder of the three-phase flow. In the reaction engineering portion of the work, he has also done a lot of effort in the development of things that all emissions control, desulfurization. I think that as we go on, things will bring into activities, will also be mentioned in our presentation. And I'll go into more detail, or at least just 30 seconds on the things that we're doing for the chemical looping research activities on the right side over here. For those chemical looping aspects, one of the things that we've also done is license and commercialize the calcium looping process for post-combustion CO2. Those work is being done in Taiwan with the Industrial Technology Research Institute, where they scaled up to 2 megawatt system, which is 55,000 tons per day per year of CO2 capture from that demonstration, showing commercial success of those activities. Also, he has started up 2 small businesses, one with Tech for Imaging, where he's been able to work on developing electrocapacitance volume tomography, visual imaging of various gas solids and multi-phase flow systems. One of the particular things that I got the opportunity to work on is trying to passivate the surface of those capacitance probes so that we can do high temperature operations for flow characterization shown on here. Where we'd be able to put this into places like in the Philippines for geothermal flow measurements in the process of operations. And of course, the things that I worked on as part of that last 14 years that I had the opportunity to work with was on the chemical looping technology development. Working on the redox reactions, where we touched on many parts of the process, including the development of that redox material that can sustain thousands of cycles of operation. Development of 4 unique chemical looping systems, all for syngas generation of chemicals, CO2 capture, power generation, even hydrogen production with sequestration for emissions control. From there, where we were able to get a little input from Luis on how we made, from the operation results that we were able to generate, we were able to license this and get an exclusive license with Babcock and Wilcox, now building off of reflecting back on his part, working with Professor Van closely, the things he mentioned is Korea always takes this 10-year pathways where you started off working with multi-phase flow systems, moving to reaction engineering, moving to chemical process. One thing that I've seen is that the capability is here to stay as far as work with background. So those are the things that I see as most impactful for the industry. One last thing I have to mention here is something that this slide was particularly hard for me to gather up. Think about like where his industry impacts is most monumental is in the maturation of the people that he knows. Of course, he's been influential in all the regards in creating multiple professional groups, leading those committee members. One of the main things that's most personal for me is how he has advised so many graduates, hundreds of graduate students and undergraduate researchers that come through the doors and be able to have the opportunity to work. And so I show a few of these groups over the generations of the years we have. One thing I have to apologize for is one, I don't have the most recent class, so I apologize I didn't take a picture. The second one is I don't have in chronological order because I don't know the generational dates necessary pre-2010. So for those aspects of maturation, one of the things that he's been the most influential is making sure our research is both important to the industry needs as well as the things that we do is fundamentally strong, making sure that we are who we are. And then of course he's been very influential on all the soft skills, making sure that my proposals are prepared well, my emails are set up pretty good, as well as the abstracts need to prepare and also the presentations are right formatted, size, and important. There's not too much white space that's still remaining on the slide. With that, I really appreciate the opportunity and congratulations.
I heard this news. I think I have to be here in person. So, first of all, Dr. Van, congratulations and thank you for your teaching, thank you for your education and coaching, and I grew a lot in the past 12 years after I graduated from Ohio State. Yeah, thank you. I want to introduce myself a little bit. I'm Fei Wang. I was born in China, and in 2006 I joined Dr. Van's group as a PhD student. I'm working on multi-phase flow, electric capacity tomography, sometimes later on ECVT, which is a three-dimensional way. Then also I will work with a couple folks on chemical heat process reactor design. I have been there for about 5 years, and after that I left Ohio State and joined P&G. With a lot of experience I learned at Ohio State, the process design, process scale up, and then I got a job in P&G working on a new platform, process development and process scale up. So I have been with P&G for 12 years, and I first started with process, then went to go-to-market product development. Then after that, I did a little bit of purchasing and touching directly to the business. And now I'm in corporate function R&D, Open Innovation Division. Open Innovation Division means to bring external technology to our company to address our challenges. Specifically, I'm working on sustainability because our company has an ambition 2040 carbon net zero. By that time, we want to choose our supply chain to be neutral or negative for carbon emission for our scope 1, scope 2, and scope 3 upstream. So with that, I'm looking for external capabilities like ecosystems, like universities, national labs, and other value chain providers to address our internal challenges that we could not be delivered by that time. So, but still, today is a celebration time for Dr. Van, and I also want to spend maybe 1 minute, because we are short of time, to highlight several of Dr. Van's achievements. The first thing I want to tell is Dr. Van is a pioneer in multiple areas. You can see that I put some item here. It's not Dr. Van is an expert in
microfluidic fluidization in full gas and solid phase. And also Dr. Fan is also expert in molecular chemistry for the catalyst design. Probably also we heard a lot of things about chemical looping process. Chemical looping process, there are a couple items like air looping, constant looping, with a different product and a different setup. Specifically, I want to highlight that the biomass chemical looping for hydrogen production with CO2 sequestration is very promising. I think if, like Luis mentioned, if that one is demonstrated successfully, there will be a huge impact to the entire society for sustainability and CO2 reduction. So we are looking for this technology too. The second point I want to mention is that Dr. Fan is also an innovator employing multi-scale approaches. You can see that from molecular level to particle and micron level to reactor scale to commercialized scale. And also for commercialized scale, it's not just chemical looping, but it's also for ECVT part, also did a lot of work. You can see that's a 50-inch ECVT reactor actually to monitor the scrubber three-phase flow structure. The third one is Dr. Fan is also an educator with hundreds of students and multiple books. Probably you guys heard a lot about the story, books both in three-phase flow, particle technology, and chemical looping. And fortunately, I was part of the original chemical looping process, and I really enjoyed the time working with Dr. Fan. I think that's about my talk, and I really want to appreciate Dr. Fan's offer me to be at Ohio State and teach me as a professor and advisor, but also as a lifetime mentor to me to help me grow. And thank you very much. And I really appreciate your help and be healthy. Thank you.
Just quickly show that impact for as a whole. So I think the last slide here, quickly go through that in 1 minute. So I just skip that thing. This is a general contribution of Professor Fan, not only for the industry, but for all of the area. I think the PDF is a good example to show that the industry that they put that together is an opportunity for industry learning from the data. That's a good opportunity there. And the other thing that's a consortium, I think Professor Research funded this consortium particularly for specified cap industry. This one this is aiding for the energy company, capital company, and as a mobile is one of the team, the team members for the consortium. This picture is a very old picture, like in that time frame, but that's the industry learned a lot from Professor Fan's research. So for ExxonMobil, right? So I think I also said that Tom Declan, he cannot attend this meeting, but he should send the notes. He shows his with regard to Professor Fan for this work. The key here that he's a manager of the downstream technology and cruise technologies. He retired, now he's a professor from Stanford. It's a key message here that Professor Fan's work is leading several ExxonMobil studies and the static absorption process. So see all the research ExxonMobil follow Professor research very closely. So that's a key part for that contribution to ExxonMobil. Also, I want to mention two quick examples. Yes, the three-phase, the high pressure, high temperature, bubble column. We've already mentioned that. Right? So the ExxonMobil has technology gas to liquid. So that technology, the high temperature, high pressure, bubble column research from Professor Group is a key information to bring the technology to technologies. So that's a key information we do the consortium. It's a contract work, put all the things together to get the information and learn and educate from Professor Fan and then put this technology to technologies. So the other example is that the new round development. It's bubble column, but this conditions outside the typical range, right? That's why we can work close with Professor Fan to build this no-flow designate. If you know that, it's the bubble column. We want to get all the key parameters. So this information that the graduates from that group make a big contribution to the expo. This is Rajiv, Sharada, and Marshall. Which also show he writes something there to show his regard to Professor Fan and Assistant Professor. Thank you for the Professor's the education. The key here that the issue that is that the professor places even trust in the students. That's a key part for what the Marshall showed here. For me, I think that all the trainings for fundamental understanding, the creative thinking, that's a key part of the particular for me is that the novel reactor development scale up. Final slide is personally, I think it is Professor Fan is also a role model. So for me, I think I just show two parts, two key parts. But I think one thing I will mention here that Professor Fan, the research horizon is so broad. So every time you talk about Fan, he said, okay, so through the dish expert, right? But he's a reaction engineer expert. We talk to the reaction engineer, we also have all the measurement technique, right? The ECVT, everything is expert down there. But also you talk to the reaction engineer, the chemical looping process, but also Professor also material expert, right? He has all the kind of material discovery and development. So each area be expert is a challenge, right? So it's so difficult. Professor Benson is an expert in so many areas. It's amazing for us to learn from Professor Benson. So show my just last word. Show my regard, appreciation for your education in the manner and weather. So congratulations again for this award. Thank you much. Sorry.
Hello, everyone. My name is Deven Baser, and I work at Dow as an associate research scientist. I graduated from the Ohio State University back in 2020, where I worked in the fan lab on a variety of chemical looping systems. So firstly, I want to congratulate Dr. Fan for this amazing honor on receiving the Warren K. Lewis Award for his contribution to chemical engineering education. I mean, I've seen Dr. Fan through a variety of lenses, right from my PhD advisor to seeing him as I TA'd for his course, or to seeing him lecture when I was a student in a classroom. And what I've come to realize by seeing him in all of these roles is that Dr. Fan always strives to learn and to expand on his knowledge. And kind of takes every opportunity to do this whenever he can. And he goes beyond that also, by using these things that he's learned, not only in the lab, in his research, but, also finds opportunities to use it in the courses that he teaches and kind of betters it every time he does. So, I really believe that it's this drive to learn and his persistence towards solving, problems that makes him an influential researcher in academia, and also now a highly regarded entrepreneur in the industry. Thank you so much, Dr. Fan, for being such an invaluable mentor to me, for supporting me through my professional growth, and for being a constant source of motivation. Congratulations again on this award.
It's my pleasure to be invited to speak here in honor of Professor Fan. The first time I saw him was in Berlin, 1989. The sixth international conference on Asia, which is now 34 years. Before I was in the circuit, I was working for Shell at that time, and since then I had been friend, colleagues, and to some extent he's also my mentor. And we have seen each other a long time, and this year we are honored to have Professor Fan to be largely into the Academy of Engineering as a foreign fellow. And that is our great honor to have Professor Fan there. And I've chosen a topic to talk about liquid solid fluoridation and gas solid fluoridation, because Professor Fan has been an expert in this area. So I'm excited to talk about this. And this is my powder technology center. This was in 2007. So I do have a group to show you now we have zero. This is my group. This is 2012. And this is my big lab, 2,000 square feet, two-story parliament lab. And those are the gas solid fluoridation columns. The highest, the tallest was 70 meters. And then liquid solid fluoridation, the very tall one, because I work on circulating. Somebody there, you can see a picture size of the apparatus I have, and I'm proud of that. We all know FCC, so FCC is a group of different food and manufacturing companies, also others, all monitoring circulating together. And it is from this idea we can see the difference and the benefit of incorporating all of them together. And different types of manufacturers, we have inter-process integration and the process intensification, so what we call PIPI. And this is a concept I adopted for liquid solid integration. And you see we could have low velocity, high velocity fluoridation, and then we can incorporate them because of the benefit of fluoride easily particle feed and removal. So we then use this concept. Here we actually put Doppler and Weiser together of liquid solid fluoridation. So, riser, high velocity, Doppler is actually conventional fluoridation, and we have liquid 1, which is lower than terminal velocity, and going up, and liquid 2, which is higher than terminal velocity, and carry it up. So the Doppler particle is down. So we have internal particle circulation, and then we talk about application. So the first application we did is protein recovery from cheese whey. So we have cheese whey coming, and we have protein. So we have the cheese whey going to become Doppler, or the proteins being absorbed onto the particles, and the particles go to the extraction column, the riser, where the proteins are extracted. So the proteins are going to be going to the buffer solution. So in this way, the protein are separated from the cheese whey, which is a waste, and to become a non-useful product. In other words, this is the process. So protein adoption on the right side, the Doppler, and then ion is loading this protein to go to the riser, or the riser is dissolved, and then collected, and then generate particles back. The benefit is that very simple and large throughput, very quick throughput, and continuously and simultaneously rapid adoption and regeneration adoption in one system. So it's very simple, very quick. So this is what we call continuous protein recovery for cheese whey. This is the first process. Okay? So that's the process feature again. Ion chain process, simple process, and easy to operate, rather with adoption and conventional food adoption. So again, what is our benefit? And what we eventually call is interactive process. Because most of ion chain process, you have to have a few columns in parallel and running one by one. And to improve efficiency for the process we have, it's about 78%, but we can go higher by making the column taller. food ion for uninterrupted ion exchange process for protein extraction. So this is the first application we did is the separating food ion. So this is where we established a few processes. Continuous protein recovery from cheese layer, and then we do the extraction and isolation of 7th and 11th soil proteins, and then continuous production of phenolic polymers by intra-soil peroxide enzyme from phenolic wastewater and fatty acid, and then we do many other things. So the 8 processes in total. So this is again continuous protein extraction process to show that what they have, but we use the same process to extract in taste. So in soybeans, Chinese Asian people are used to the taste of soybeans, so we can drink it, but many North Americans do not like the bean taste. The bean taste is actually related to the 7th and 11th protein of the system. So we use our technology to extract out those 2 proteins, and then the soybean become very friendly tasting to every people who are not used to the bean taste. Okay? So we have success with that. So that's another technology. And this technology is even more beautiful because it convert waste, not only extracting waste, but also converting the waste to useful product. So I don't have a pointer, that's okay. So what we have is in the left for the rice, they take away phenolic wastewater, and then we use SBP soybean enzyme to absorb the phenol and then transfer it to the downward side. But at the same time, we're putting 5% ethanol into the rice, into the downward, and then it combines with extract phenol to make the phenol polymer. And having this cycle. But this cycle has 2 purposes. One is to extract the phenol, and second, to work for a product. So this is the process. The phenols come in, we put the hydrogen peroxide, and then absorb onto the particles, and use ethanol, and then we will fill the phenol polymer. So we are achieving the process. And then this process is with magnetic catalyst and the reaction of electric metal reaction rate. So this is what we have done. So transfer phenol from first water is a useful product. Another process we have done is to convert lactic acid fermentation, to combine lactic acid fermentation and extraction, because the lactic can be made from fermentation, but the lactate produced prohibit continuous reaction. So what we do is we have the lead solution, the fermentation happening at one side, and from there we take away the lactate, and then to absorb it onto the particles and take away the lactic acid and allow the process to continue. Again, this is the process, so we make solution, and then on one side of that is the fermentation column, and through that we go to the extraction. So the double looping is the ion particle process, two particles. Solution and the lactic acid production at the same time. sold for $500 just 2 years ago. Fortunately, it's not fully sold, but actually it was sold after 1 year our patent expired, so we didn't get any money. Didn't know that we got our name. Okay, so I didn't get any money out of it, but I did for 1 year they declared us licensed. But the license is we pay the patent fees because we didn't charge them. It's a startup company, large company, I think $10,000 a year, but we did not money to maintain it. So only 1 year, the management fee was less than the license, so just a couple thousand dollars. That's it. And then they don't get sold. That's a good thing to do. So, the last one I'm talking about is enhanced wastewater treatment process. It's a revolutionary fundamental change to the wastewater treatment process. So basically, you can imagine the wastewater process will include aerobic, anaerobic, anaerobic, aerobic, and septic. And all of them can be food like that because they have involved microbes. And the particles are given the sacred, the microbe safe haven to stay in the system. Of course, wastewater is a real problem. And many areas in the country is still contaminated. In Canada, we are talking about but most time when you treat wastewater, what you do is you pump the flow into more areas outside the city and to treat it together. Okay. And then our process is to package it into this. To provide safety for the microbe to stay. So now we go to the process that the biological process takes away 95% of the cost. So what we do is instead of activating a sludge system with the high process we allow the stack, which is the microbe, to grow onto the molecules. And then we increase the density of the treated microbe by 10, sometimes 100 times. So it will increase the efficiency of the process. So going out surface area for microbes to grow, and then see the microbes grow, and they are the workforce of treating wastewater. So by putting the gene, we increase the surface area and provide the place for the microbes to stay and grow. And this is the test. Advantages I will go into detail, but you can see we worked for almost 20 years on this test. Very long time consuming. When you achieve your condition, it takes at least 2 months to test the result. Because that's how the microbes stay. So the benefit, as I showed yesterday, essentially is that you would have wastewater, you pump the drinking water into the system, and then you have wastewater coming down from the filtration and treatment. But with our, and this is with our technology, we can miniaturize the reaction, the wastewater treatment units, we can put them into the pump itself, so we can eliminate the wastewater plant. So everything like eyewitness is here, we can have something in the basement treated instead of flowing out. For example, this is our design, and probably we would like to just have a pump underneath and to get it treated. Obviously, it's a million years for us to get it clear, and then from very small limits, we have to go back, and show you the time it takes. That's why I say almost 20 years to do that. And we do it for our mobile units to do demonstration. And this is the biochar treatment facility for restaurants. This is
30 years. I just noticed that some time is the first chair of this forum to make this international. And more and more Chinese scholars, students were involved in the development. And Professor Jing also want to celebrate advanced achievement in research and education engineering within this World Rules Award. And Professor Jing want to thank for the long-term support and help in their research of the EMIS group, which was initiated by Professor Fan and Professor Huang. The photo shown here is, I think it's taken in 2008, and Professor Fan received the Einstein professorship from the CDS. So Professor Lee is really looking forward to meet Dr. Fan in person in the future. And the second message is from Peking University. The Vice President of Peking University, Professor Qin Lang, want to congratulate Dr. Fan for this achievement. And Professor Dr. Fan has visited Peking University many times, and this photo is 2018, and Professor Fan is giving a tuition lecture for the undergraduate. And in the lecture, he emphasized the importance of critical thinking, scientific research integrity, and effective implementation for the undergraduate. And those are long-lasting impact to the Peking University students. And you see on the last picture shown here, that's the graduate students in Peking University. Chensai is discussing with Professor Fan. He was my PhD. I followed by him for his PhD program. Professor Jing and currently he's a professor at Peking University. So he was in the US for 2 years, a postdoc, and Professor Fan has also helped him and committed with him and helped him for certain areas. And the messages from Chinese Society of Technology, and they want to they really highly value Dr. Fan's contributions on the multi-phase reaction engineering and particle science and technology development. Okay, there are more messages from Professor Cheng Yi, and the students I will be there later. The second part is the routing for energy microprocessors. As we can see, many research group has developed routing classification combustion, but they developed to certain technology readiness level. Ohio State is the only one pushing this to TRI 8 or 9 for commercial demonstration. Why we can do this? Because we know the principle of fundamental, the first principle of the particle technology and the science behind that. And I was lucky to join in this research program in 2007. So before at the batch scale, and then leave the group by 2014 and join Peking University. So in between, I was attending the scale up from 2.5 kilowatts to 25 kilowatts to 250 kilowatts. So it was very, it's good experience. I feel it's very rare experience for PhD student training. And Dr. Fan has named the technical routing classification. And as you can see in Wikipedia, the first several references for technical routing reform and classification is from Dr. Fan's book and literatures. And from there, we use the modified diagram to group technical routing to oxidation and partial oxidation. And that's related to the two books, right? The orange book and the dark blue book. And the right-hand side is the fundamental research for metal oxide reduction chemistry. And because we know the group of different particles, and we know particle technology reaction engineering, so we designed the technical routing record system for gas solid, comparative law for high quality syngas production, and the gas solid uncomparative law for low hydrogen production. So that's a surprise to the field because Dr. Fan was well known for the fluidization. Everyone saw Dr. Fan will develop the technology using fluidized system, but actually we did using fluid. So that's because we know the principle behind. So that's why I feel I was trained so much and I want to convey that when I started my career back in China. Dr. gave me suggestions where we should start. The first suggestion is Dr. gave me two suggestions, directions. One is the micro-oxide without chemistry, the other is the moving back system. So the first one, we started for iron oxide preferential oxidation. We found there's a new regime for together with some fund. We just published one paper in CEJ, I think 2 months ago. And the Xiaofeng is the first author, also graduate from KP University, and Dr. Fan is helping to come to US for the PhD program. And we found a really small regime, thermodynamically feasible for CO preferential oxidation in hybrid-rich gas. And we also found the material gamma phase Fe2O3, which has the inverse carbon structure with the same as Fe3O4. So that means we have very straightforward oxygen conducting ion conducting phase China, which is different from the conventional alpha phase Fe2O3. And we also developed the new operating line in the modified Riester diagram. Why we do this? Because one of the always ask us to can we further improve the efficiency of the system. So we know the problem for the significant moving CO conversion to CO hydrogen is low. So use pure iron oxide, we can only achieve CO to hydrogen 70% conversion. But if we do nickel and iron carrying pure intelligent system using the moving back system, then we can do that. And we have to do that in the Riester diagram. And because I was trained by Dr. Fan to scale up, so I also collaborate with ENN for scaling up the calcium routing for SMG process in China. And this is the development. You see, we finished the megawatts level pilot scale study within 3 or 4 years. Why we can do that fast because of the training and save. And as you can see the results with the inverse beam carrier pattern, we can produce hydrogen to CO ratio of 1.5, and with CO carrier we can make hydrogen to CO ratio larger than 3. And we want to further improve this, so we are doing some mathematical modeling, and there are some technical modeling and modeling process simulation. And that's also a suggestion from Dr. Fan. We can publish some good paper from those models. And I'm also teaching 2 courses in KP University, multi-skill chemical engineering for undergraduates and chemical engineering for international graduates. So right now I'm teaching international students. I'm trying to teach master and what I learned from Dr. Fan and trying to implement that in China. And those are recent footprints for Dr. Fan in China. You see in Tsinghua University in Nanjing, International Chemical Grouping Conference, the ICT, KP University, JLS 14, and the usual ground is for high school education. And Professor Sun Gongli could not make it here, but he provides the pictures showing the students in China. And this is Yitao Zhao. I will highlight Yitao Zhao has a long conversation with some time before his life Columbus, and the fan suggested to encourage the company in the family and then work hard. So that's the sequence of those 2 pictures. You better work hard. And this is Sui Luo. He's currently working as an analyst in CIPIC, and Dr. Fan say good study is Dr. Fan learned the routing theory. And this is his finding, it's 2 pieces. And Professor Zhou Xiang from Jiaotong University, Seattle University, his main message is that he quite appreciated the interact of Ohio State, and he carried the tradition in Xi'an. So every year, semester, he will do the students. And this is the idea that the Dr. driving us, taking us from China, then we will carry back to China. This is the distribution in mainland and Taiwan. And I want to summarize with I don't know if it's suitable or not, but each of the student of us can be considered as a single particle, no matter skinny or choppy. But we want fireside grouping group, healthy grouping group, and group E might be CVT phase working in. And Dr. Fan will teach us in accordance of our activity. So that's very important. We were specialized training. So there's no standard training. Dr. Fan knows the features of each of us and train as well. And then there will be on the right hand side that's the liquid solid flow region and from Professor Drew's lecture material. Basically, Dr. Fan will suggest us how to grow fast in Korea and how to do that also the same for the technique. So you can some certain time we are slow, we are doing internal circulation, not the external circulation, not the fast transport region, but that's life, and Dr. Fan always tries to us. So I really appreciate that. So I will leave the floor for Professor Chu.
Okay, so it's my great honor to be here to congratulate Dr. Fan for their achievements in education. Actually, Dr. Fan is a very close friend of my supervisor, Professor Jin. I think for more than 40 years. Professor Jin is the standing right-hand side of Dr. Fan, so I was also in the picture right side. So, just listen to the voice of Dr. Tsai. Actually, Dr. Tsai is my big brother because we come from the same group, Professor Jin. And his thesis was co-supervised by Dr. Fan, Professor Jin, probably in 1989. So after that, many students from the Department of Chemical Engineering and also the Department of Engineering Mechanics of Tsinghua University joined Professor Dr. Fan's and finally became members of Dr. Fan's club. And it's kind of a big family. And for myself, I actually have no any experience studying or working with Dr. Fan. Just a pity, but remind us, Dr. Fan is like my lifelong mentor, and as well as a friend. So the first time for me to meet Dr. Fan actually was 1999. It's an ASCGM meeting in Dallas. At that time, I was a PhD candidate, but also I was working in Philadelphia in the Netherlands. And several of those students actually recommended me to apply for postdoc positions. But I had a job in the Netherlands, so I missed the chance. And otherwise, maybe you're one of the members. So, but in 2003, I started my career in Tsinghua University, and then I had other chances to actually Dr. Fan at different conferences, like Foundation, CFP, ASCGM meeting, and also history series. So, but at that time, I was so young, so still a bit far away from Dr. Fan. But in 2007, I get a chance from Tsinghua University, I get a chance to talk to Dr. Fan, because Dr. Fan is invited as a chair professor to visit our department. And then several days later, I was assigned to do everything needed, everything, and the schedule, everything, the teaching and lecture. So actually it's very difficult, but it's not difficult because I know Dr. Fan is really energetic. He has a lot of things to talk during the lectures. So I remember in 3.5 days, Dr. Fan gave 7 talks, 7 lectures, and one of them is about the teaching course of chemical product design. So many professors and many students from Tsinghua University, different departments, and joined Dr. Fan's lectures and the teaching course. So we were really impressed by his attitude to research, especially to teaching. And after that, we had a lot of chances to meet almost every year. And in 2009, because of the contribution, Dr. Fan's contribution to education and research in China, so he was elected as a member of Chinese Academy. So a lot of things to talk. So finally, I think at last, there are several questions. Because my supervisor, Professor Jin, now is 88 years old. He cannot come to these events. So I something on behalf of each of us. We also we both have to thank Dr. Fan for the education and for the collaboration and for everything. And finally, congratulations to you for your big achievements in education.
Hello. Can you all hear me? Okay. So, well, first of all, I mean, thanks a lot for giving me a chance to talk in an audience which is way more experienced and way more educated than what I am. And I humbly thank you all for giving me this opportunity to talk here and specifically talk about the Indian perspective on, or like Dr. Fan's impact on the Indian society over these years. Now, Indian scenario, the energy scenario is such that right now we have 55% of the energy demand is supplied by coal. And it's, I mean, to everybody's knowledge, Dr. Fan has developed around 8 technologies on clean coal. And they have helped this field overall to move towards, move in the direction for developing and getting better, efficient, clean coal technologies developed all across the world. That's one. Secondly, as an educator, Dr. Fan has been involved and has had multiple trips to India. One of them was in 2007, and then the other was in 2013 to my alma mater, Institute of Chemical Technology. And he has been there and he has been working on a number of, he has been a member and chairperson on various committees in the Indian educational societies. This is, I mean, I also involved in it. Now, specifically talking about the current energy scenario and where all the developments are going, India is a big producer of iron and steel industry. And currently, the energy scenario is such that iron making is very greenhouse intensive. It's very carbon intensive. And as a result, in the recent times, we have, now it's, I mean, the press release has recently come out. So we are now currently working heavily with Tata Steel in trying to develop a technology that, which Tata Steel has licensed from the Ohio State for developing what we call as a redox energy recovery technology. Iron is mostly made from blast furnaces, which uses metallurgical coke along with iron hematite. And it generates a waste gas stream which still has a lot of carbon monoxide and hydrogen. And we are currently working on processes where this reduction potential which is present in these waste gases can be leveraged for generating hydrogen. And that's another technology through which we are trying to generate green iron or a less carbon intensive iron and trying to move towards in that direction. With that, Dr. Fan has been, so with that point I want to stress in the big picture of this whole talk wherein everybody has spoken about his impact on the different sectors, especially focusing on the Indian sector and the steel making and the coal industries, which are two of the biggest industries in India. Dr. Fan has been heavily supporting on those, and we will be looking forward to some very important developments upcoming in the near future on those. With that, on behalf of all the current students of the lab, I congratulate Dr. Fan for this award, and you have been a great mentor to all of us, and we always love working with you. Thanks a lot everyone for your patience, and thanks a lot for listening.
Hi everyone. First of all, thanks a lot for allowing me to present some of the recent work we are doing with India. In a room which is full of way more qualified and experienced people than what I am, I'm simply humbled by this audience and I'm honored for this opportunity. Like I said, there are a lot of way more qualified people to talk about this topic, but I would like to bring a very different perspective, especially about the current endeavors of Dr. Fan's scholarship in India, and also the work we are doing in the recent times with the Indian steelmaking industries. So, Dr. Fan's association with India has been there for a very long time, especially for a country like India, where 55% of the entire demand of energy comes from coal. Dr. Fan's work on clean coal technology has been cited worldwide and has allowed to basically take this entire field, move in a cleaner way of energy production for coal. Uh, Dr. Fan has so far invented around 8 technologies in this clean coal world, and they include technologies for CO2 capture, sulfur, NOx emission controls, production of electricity, syngas, hydrogen, chemicals, liquid fuel productions using chemical looping and other technologies. So, to give you like some of the background, Dr. Fan has visited India more than a few times, and he has been involved with a lot of developments happening there in multiple ways. Like you can see some of the points I have shown here. He has been a part of, has been as a speaker, and more recently he has been elected as a foreign fellow on the Indian National Academy of Engineering, which is the country's most prestigious body of engineers, engineering scientists, and technologies. Dr. Fan is a author of 6 books, which are worldwide used, including India. And so far, he has guided more than 40 PhD students for their dissertation. Now, speaking more in terms of the commercialization efforts, which we are doing more in the recent times. So, OSU has recently licensed their redox energy recovery technology to one of the biggest steel producers in the world, which is Tata Steel. Uh, and this is the press release which was done from OSU regarding this. So, how does this technology work? Basically, we use a chemical looping platform, and in one reactor, we take the waste gases from the steel mill and they reduce the oxygen carriers, which is like the first step called the reducer. Now, these reduced oxygen carriers will then react with steam in the second reactor to generate hydrogen. Um, Now, steel making is currently a big contributor to the greenhouse emission gases, and there are worldwide efforts going on to curb these down. Now, in a blast furnace, iron ore is mixed with metallurgical coke and fed together into a blast furnace where at the end of it, the iron oxide is reduced. And at the same time, a lot of outlet gases which contain steam, CO2, at the same time have a lot of hydrogen and carbon monoxide are generated. And we are trying to leverage those using this redox energy recovery technology for generation of hydrogen, which can be then used back into the system. Now, some of the advantages of this proposed system is that the system it can be very seamlessly integrated into a steel mill with minimum modifications to the infrastructure. At the same time, it would help in lowering down the carbon intensity of the steel production. And basically, this is a current effort. Hopefully, soon we will hear more news about its commercialization. Uh, Now, talking more in terms of the work of some of the previous students, Dr. Pan, I have wishes from some of the past students, such as like Dr. Raja Zadhav. He is currently in Chevron Corp. Next is Dr. Nihar Falak. He is currently in Shell. And I also have a few wishes from Dr. Shweta Ramkumar, who is currently in ExxonMobil. I would like to also thank the current lab members, including Sonu Kumar, Ashin Sani, Tanay Zavdekar, Sudeshna Gun, Ishani Kudwa, and Shekhar Shinde for helping me out with making this presentation. And congratulations, Dr. Fan, on this big achievement. I'm really grateful to be your student. Thanks a lot.
So next speaker is a special guest. So you notice that his last name is same as Dr. Vance. And in fact, I think I met him when you moved up to Princeton when you started doing his undergrad. Now, many years later, he's a professor, tenured professor at Stanford University doing amazing work, and we collaborate. So this is really exciting legacy of Dr. Vance.
Thank you so much, Melissa. And congratulations, Dad, on this award. It's so great to see so many familiar faces. I think the idea of academics having a research family is often a term kind of thrown around. And as long as I can remember growing up in Cofalt laboratories, doing my homework next to a lot of you, I think I can really say that it really has been a family-oriented experience for me and the entire fan club throughout my entire life. I've also kind of learned in talking with some of my dad's former students that going through the LS fan experience is a true rite of passage that is potentially the hardest time in life for any individual, and that people work harder for longer and are more productive in his group than at any time in life. And I have to say, having grown up with this, I can completely believe this. And I just want to share, as someone who essentially has been mentored every single day of my life, what this is like. And I think it's ultimately no surprise that I'm a professor at Stanford, that my sister Jolene is a professor at UCSF. We drunk the truth very early on and haven't stopped. The first thing I want to talk about is the example he has set for me and my sister in work ethic. There's just no one who works harder than my dad. I think it is just incredible. Again, ever since I have remembered, my dad, every Friday night when most people are trying to decompress, he's working. And he's not just working, he's probably calling one of you on his phone. He loves to talk. It doesn't matter what time of day or night that it is. And I know about this because it's very loud. And my mom tries to get him in a part of the room where, it's contained, and then, never really happens. But this is Friday night. And then Saturday morning, it's the same thing. He just is calling one of you. He's had this idea between Friday night and Saturday morning that he just has to discuss. It can't wait until another time. And that's just how it is. I mean, not a single day, not a single hour goes wasted. And it's not like a secret or anything as to how you get the incredible productivity that he has. Anyone who works like this is just going to clearly work cumulatively many thousands, tens of thousands of hours more than the average person. And so the fact that, and of course with Sunday, right, this doesn't happen because he's of course at work running these famous Sunday group meetings. You should all just know, and I see some of my group members here, that I've attempted this. I've tried calling them off hours and I get sent straight to voicemail. So all of you are just extremely dedicated to the fan group cause. And for me, when I think about my career, work ethic has been, there's no substitute. I mean, you just have to work really hard to have any type of success, no matter how hard, no matter how smart you are. The second thing I want to talk about is persistence. I think part of this is short-term persistence. I think part of all those calls in the middle of the weekend is, if there's something he wants, he's going to get it. And stringing along those short-term wins leads to, long-term wins. But from the point of view also of like incredibly long-term persistence, just knowing the time of years to decades that my dad has worked on these moving processes, it is really hard to have that kind of stamina. I mean, I've now been an academic for 10 years, and that's a small fraction of how long my dad has thought about a single problem. I mean, I remember high school, and you kind of listen to your parents when you're in high school. I think that's when I started hearing the word looping, and it was like kind of an interesting thing. And then in college, you started talking about it more, and it started to scale up. And then when I was in grad school, it was still the same thing, but now it was 6 stories tall in Alabama. And now I'm faculty. I've been at Stanford for almost 10 years, and he's still talking about the same thing, now in the context of commercialization. I mean, that is just incredible persistence and stamina to engage in an incredibly difficult problem that spans molecular to refinery level. It's ultimately the only way to even get to the stage of commercialization has been to do this literally for an entire career. That's the only way, and to be the best at it. And lastly, I just want to talk about vision. I mean, I think the thing about academia is you have the smartest, hardest working people almost exclusively. I mean, these jobs are impossible to get, and it's hyper competitive. And to imagine having like an edge is hard. And to imagine being able to just somehow supersede what everyone else is doing is hard to really imagine. But it just comes down to vision and being able to just think in a completely different way from everyone else, figuring out what important problems are and approaches are, where I know, especially for my dad, he's not just looking to do work that is motivated by energy, but he's looking to really push translational, scalable energy solutions. And that's a very different thing. That's what differentiates what he does with, well over 90% of the work being showcased at this conference. And I can say as a professor that no one tells you what to do. I mean, it can be a pretty isolated job to craft your own vision, but I think just by seeing him do it himself, a big part of me now working in scalable electrification concepts for sustainability is to attempt to hit that nexus of interesting academic questions that have the opportunity to scale and to really impact the world in a positive way. So I know for all of us who have known my dad, for all of us who have been in this group, even as lifelong members, that we are all instilled with these very basic tenets. They are not complicated, but just in doing it day after day, after week, after month, after year, after decade, that's he's just really shown by example what it takes to be great. So congratulations, and this award is very well deserved, and I'm proud to be here to say some of these stories. Thanks.
So, as one of the mentor member, I still get phone calls. So I'm privileged to still getting your phone calls.
Me too.
Yeah, yes. And we still have amazing research discussions or the big picture to really detailed science. I really appreciate that. And sometimes you also talk about, okay, what are you doing? What are you doing with your career? Those talks are really helpful for me as well. Always kind of putting to the right direction. So let's invite Dr. Fan to talk about closing remarks about
for your patience staying so long for this 5-hour session. And Jonathan, hear what you say to you. Basically, you can see my wife, the circle around my family, and the extended family, my groups, and the department is part of my family. I have always said so, and nothing else is there. And I'm overwhelmed with comment, with thoughts from each one of you. That's reminiscing. Just look at the woman's photographs. 45 years, I still remember, when I came in for interview for the family organization. And over the years, interacted with the students and the faculties and department faculties and then the faculty beyond chemical engineering and I was saying, I think Maca is the places in my blog. It's actually my children's blog as well, even though they're in university, they pretty much every single Ohio State football. And so the dedication for us in Columbus is making us really the most devoted committed residents in Columbus and Ohio State campus. I want to thank Alisa, the student, to put this program together. And I know that they have spent enormous amount of time and they engage so many people because the group which associated with me and my team has been very large. And I always advocate not just within the very restricted area. I think I always think beyond. And in some organization, I sort of help initiated and always with the goal of being international. And students in the group, many are international. I think there is no boundary. And we promote diversity. In fact, we have to practice diversity all our career. And these are the people who are just so amazing. And being honored with this particular award to me is the highest moment of my professional career. And I thanks very much you and those colleagues of the support the letter movement and colleagues of different universities. Because there's nothing always to be more honored and to honored for your profession. In our profession, here is education. And much of the activity today require you to research. And of course, research to me is just to create knowledge. And so we can pass on the new knowledge to the student, to the new generations, to the practical industry, and so forth. And so the part of the educator is to communicate and convey those new knowledge. And so we will live in a better society, that will be better served, and the better community and so forth. So each one of you, mentioned how the work experiences really is very touching to me, and I just feel so many years, a few decades have passed by, so fast, and I want to sort of continue to reach that cherish each one of the moment, and because time just flying fast, and I'm so honored to hear not just remark on your experience with me, but also the remark and the messages you convey with respect to your research. And I think a number of you indicates the kind of work you're doing, and they are all stand-out. And I want to mention many of the speakers, they are the leader of the field. And each time when I sit there, it's always learning something new. And I think it's always a part of the education is to keep learning, and as part of research is to continue promote and moving forward as well. to my student, this particular occasion coming from so many different places and so far, and I'm really grateful for you to do so. And I just mentioned we have the speakers or participants coming from Singapore, Taiwan, China, Australia, Canada, Mexico, in the UK, in Europe, and so forth. And I'm just so, touched with, the friendships that were together for so many years. It's not just, doing something together, but at the end, and you see some of the influence which I had on you, and really and we work together for many different things. Each impacted you really made me so proud, and I think one of the comments made, your success is my success, and because any little influence on you is the greatest pleasure of myself. And I want to also mention a few people. I did not come to this particular situation totally on my own. I was very fortunate and lucky, to get the support from my mentors. So I wanted to, get this privilege to mention them. And Professor C.C. Chen, my advisor at National Taiwan University Chemical Engineering. I did a bachelor thesis with him, and he has been with me and communicated, supported all this before he passed away. And the Professor C. by the way, went to just was my master thesis and a PhD thesis advisor at West Virginia University. L.T. Fan was my cousin, as well as my postdoc advisor at Kansas State University. So he has been the reason I majored in chemical engineering, because when I was in high school at the Taichung University, and I just admired him so much. I said, well, I wanted to be, I want to be a chemist, despite my father wanted me to be a medical doctor. And then when it comes to the entrance exam of the university, I signed in, chemical engineering as my first choices there. My father did not talk to me for several months. But I think in the family, I was admiring, so passionate about chemical engineering. Many of the other colleagues in the United States and part of the world, we like to honor them as well. Maurice Berkeley, West Ontario. Bob Rocky, West Virginia, Ohio State. John Davidson at Cambridge University. Norman Epstein from UBC. Benton Lee, University of Tokyo. And Norman Epstein. Norman Lee in Chicago was working with him before. Charlie Su, UIUC in Rome. Barry Tommy, ExxonMobil. Chi Tian, Syracuse University. Danny I.C. Wang of MIT. Jimmy Wei of the Princeton University. Vincent Kwok of the Institute of Metallurgy of the Chinese Academy of Sciences, Beijing, and Jack Zhang. So these are the people who helped me, and there are others. Really, this time, I consider myself as very lucky in growth in my career, and I can always come. And so I think in a career, there are some portion of luck in me, and I always consider myself to be so lucky in many different ways. So it is consider myself as a privilege, to work each one of you in a lifetime. And as I said, I will not repeat the past way. I will not repeat place any one of the students can, from the process eventually work together. There's a certain reason why we work together. And then my colleagues at Ohio State, and then the greater profession as well. I want to thank my wife. Everything I'm able to do is because of my wife. She sacrificed a lot. And she raised two beautiful children. I think I'm very unfortunate she couldn't be with us because of medical appointments. And thank you to the greater Ohio State family. Wonderful department. I feel the support that I received. You can see many of the presentations showing the installations. Ohio State department, I'm not sure how it's and so many of the things I was able to do with all my students that we eventually impact the industry. It's because of the experiences in Ohio State. It's supported by the department, and college, and university. With all those things, I want to thank each one of you who stayed along here in the session and as a speaker. I will always remember this occasion and the messages you share with me, and you will be with me as long as I live. Thank you very much.
Ellis is very healthy. He's jumping up and down right there. So I want to thank one special person, to Fan Xing Lee. He really helped us a lot to make this occasion very nice. Thank you, Fan Xing. We had to leave a little early, but I would like to thank all the invited speakers. Thank you. And of course, all the current students. You guys made it so wonderful for all of us, so thank you very much for your hard work. And finally, congratulations. Picture, or we will take a picture. Dr. Fan loves pictures. So family photos, we're gonna do that. But Dr. Fan, congratulations again. You're not done, so please continue, educate us, teach us, and guide us, and mentor us. So thank you very much.